Okay, we're going to start our new unit. It's on exponential functions and equations. So today what we're going to do is look at what the graphs look like and do some regression. So to start with, we'll figure out just a basic exponential graph. So if I gave you the equation y equals 10 to the x, it's a little bit different than what we've done before because now we have an equation with x as being our exponent. So that's what makes it an exponential equation. So an equation with x as the exponent. So any kind of equation that has something to the power of x, that'll be our exponential function. So if we were to do, let's just do a simple little data table for this one. So if we plug in a 0, 10 to the 0 is 1, not 0. So 10 to the power of 0 is 1. If we plug a 1 in for x, 10 to the power of 1 would be 10. If we plug in a 2, 10 to the power of 2 is 100. So you can see we get bigger and bigger, faster and faster. If we put in a 3, we get 1,000. So you can see we're getting larger and larger and larger. So let's try a negative 1. If we put in a negative 1, we'd have 10 to the negative 1, which is 0.1 on your calculator, or 1/10. If we put in a negative 2, we would get 0.01, or 1/100th. So you can see sort of the pattern. As our exponent gets bigger and bigger, we're just timesing by 10 each time, and as we get smaller and smaller, we're dividing by 10. So if we were to graph this, you would see that we get a graph. So when x is 0, we have 1. When x is 1, we get 10. When x is 2, we get 100. So our graph is getting really big, really fast. And when we go in the negative direction, when x is 1, we have 1/10, 100th, and so on. So our graph, our exponential graph, looks something like that. Okay, so for an exponential curve, we get the looks sort of like a C shape. So it's rising from the left to the right. It gets larger and larger. And you can see we never get below the x-axis. For any of these kind of questions, we'll see that our domain, in this case, is any real number again, once again like we did before. So for domain, we have XER. For our range, we have everything above the x-axis. So we just write that as greater than 0. Not equal to. We'll never get it equal to 0, but we'll just be greater than. And we have our x intercepts because it never crosses the x-axis. We have none. And our y-intercept is we have one y-intercept at 1 in this case, so it would be at the location 0, 1. Okay, so you get the idea. It's pretty basic equations, pretty easy to graph and figure it on your calculator. What we want to do now is let's compare that graph to y equals 5 times 2 to the x. Okay, so a lot of people think these graphs are the same because 5 times 2 equals 10, so we think it should be exactly the same, but it is not the same equation. Okay, so what we want to do is let's graph that one quickly to see what it looks like. So if we graph y equals 5 times 2 to the x, what we do is if we just type that in on our calculator and sketch it, the graph looks similar, but in this case it's crossing through the point 5, and it's not quite as steep. So if we were to graph both of them on the same graph, so our last one, our y equals 10x, looked something like that. Oops, it doesn't cross through the point 5. That one crossed through the point 1. Okay, so our y equals 10 to the x was more like that, where it crossed at point 1 and where this other one crosses at point 5. So you get the idea of the difference between the two. So let's kind of figure out why it's like that. So if we actually were to plug in numbers in this case, so let's try that. So let's do our little table again. So if x is 0, 5 times 2 to the 0, this case is 5. If x is 1, we have 5 times 2 to the 1. So we get 5 times 2 is 10. X is 2, we have 5 times 2 to the 2, which would be 20, and so on. So you can see the difference between the two charts. When we did our other one, let me just put the other one back up. So when we had 10 to the 0, that was 1. We had 10 to the 1, that was equal to 10. 10 to the 2, we got 100, and so on. So you can see in this case, the difference between the two equations is sort of where they're starting and how much they're going up by. Okay, so let's write out each equation and sort of use that to compare. So in this case, you can see our starting number, or our y-intercept, is 5, and when we just did y equals 10 to the x, what we're doing is we're kind of comparing that. We have no front number, but remember that would be the same thing as having a 1 there. Okay, so if you have a 1 there instead of a 5, you can see that our y-intercept is a 1 this time. And then for our 2 to the x part, oops, I got my brackets in the wrong spot. Our brackets should be just around the 2. So now you can see in this case our 2 is sort of what we're multiplying by, or the multiplying rate. Right, because our numbers are doubling. We're going 5 times 2 is 10, times 2 is 20, and so on. And we'll call that the base. So the base number in this case is 2. And you can see over with the old one, in this case we're multiplying by 10, so our base is 10. So when we do calculator work for these kind of equations, when we do calculator regression, you'll do the exact same thing we did before, except when you choose your regression, you're going to pick exponential regression, or EXP regression, and the form that it'll give you is y equals a times b to the x. So remember that our a is our y-intercept, and b is our base. Okay, so let's do one more that's a little bit different. So let's look at the equation y equals 8 to the 1/2 x. Okay, so in this case, if you graph that on your calculator, what's going to do, it's going to go backwards, but it's still going to cross through the point 8. So let's use what we just learned. So 8 is our y-intercept. So that makes sense. But now in this case, 1/2 is our base. That means instead of doubling or tripling or timesing by 10, we're dividing by 2 each time, or we're cutting it in half. So in terms of our chart, when x is 0, we're starting at 8. Our y-intercept was 8. When x is 1, we're going to have half of that. It'll be 4. When x is 2, we'll have half of that again. We'll have 2, and so on. So 3 would be 1. 4 would be a half, and so on. So you can see we're getting smaller and smaller as we go down. Okay, so that's it for the exponential graph. So it works pretty simple. So the front number is sort of where you're starting, and the number in brackets is where what you're multiplying by each time as you change. Okay, so we'll stop there, and you can do the assignment where you're just examining these graphs and doing regression. So remember, for regression, it's been a while since we did it. Just remember when you type in your data table, so you go to your stat edit, put your lists in, graph your points, choose stat calc, pick the exponential regression, draw your line, and then from there you can solve whatever questions you want. If you forget, go back on the Moodle. There's a little list on how to do regression. And that's it.